So this video is something of a footnote to my fourth lecture. And in this video, I want to talk a little bit more about the general rule I discussed for finding the smallest voice leadings between any sort of chord or scale. In particular, I want just to practice applying the rule to a scale that you probably haven't worked with before, and then I want to give you not quite a proof, but at least an intuition about why the rule works. So first of all, just to remind you of what that rule was, let's try to think about how do I find voice leadings between two versions of a scale that I'm not familiar with. And in particular, I want to think about what's sometimes called the 6-note blues scale. Talking about this, especially thinking about like systematic transpositions of scales, will probably horrify blues musicians just about as much as my other discussions about voice leading horrify classical musicians. So again, I don't want to give the impression that I'm giving a really deep stylistic understanding of any particular musical style, but we're exploring how specific mathematical principles might relate to some of the things that styles do use. So don't take my word about anything blues related for granted. Nonetheless, I think we can come up with some cool results. So you can see up at the top here, I've written out what people call the 6-note blues scale with C as the tonic. And down here, I've written out the B-flat blues scale. So in principle, the same scale, just transposed down one whole step. And we want to find the smallest way to connect these two scales. My rule from last time says if you think about them as scales, that is, you think about them as having an order to their notes, if you want to look for the smallest voice leading, you only have to look for the connections that preserve the order of the notes. So, for instance, one thing we might do is we might just think about taking the tonic of the first scale to the tonic of the second scale. And if I do that, then I just take all the other steps of the scale to their corresponding number. You can see I've written out in red these numbers right here, the first, second, third, fourth, fifth, and sixth notes of the scale. And so this is one possibility that we might want to check. This voice leading could result, has the potential to result in the smallest connection between the scales. And you can see each note here would move down by 2, which means that there's 2 times 6 or 12 semitones of voice leading motion between the two scales. 12 seems like a decent amount, but maybe that's the best we can do. We do know, for example, that if I were dealing with C major and B flat major triads, just shifting everything down a whole step does work out to be the best possibility. So this would be one thing to consider. But it's not the only thing that our rule would ask us to consider. For instance, another possibility would be if I take the root not straight down, if I take the first note of the C blues scale, not to the first note of the B flat blues scale, but maybe to the second note, like this. You can see that I might intuitively want to do that since that would involve moving C up a semitone to D flat. If I choose to do this, then my rule says that given this, everything else should just shift up one step in the scale. So this note, what was the second step of C blues, should become the third step of B flat blues, and so on. Now the last note, the sixth note of the C blues, should go to the root of the B flat blues. So one thing I could do is I could, shift the tonic or first step of B flat blues up an octave, so I can just map this 6 onto this 1 over here. Or if I don't want to always write out that possibility, I could say, okay, well, this maps sort of across like this. So that's another possibility that we should consider. And if I were going to add up all the motions that this makes, C going to D flat is a motion of 1. E flat to E flat is 0. F to E natural is 1. F sharp to F is 1. G to A flat is 1. And B flat to B flat is 0. So overall, I only had to do 4 semitones of motion to connect the two scales this way. That's a lot better than 12, which was our possibility before. And if I systematically check all of the possibilities, it will turn out that this will be the smallest voice leading. We don't know that officially until we check the other possibilities. We've checked 2 out of 6 possibilities that my rule from last time would suggest. The other possibilities would involve doing things like the following. So for instance, I might consider taking C and moving it to E flat. Scale degree 1 here becomes scale degree 3. It shifts over 2 steps in the scale. And the same would be true. 2 would become 4, 3 would become 5, 4 would become 6, 5 would become 1, and 6 would become 2. We've shifted or kind of rotated everything around, but the order is preserved. Last time I suggested that it was also possible to visualize this in terms of, let's say, a circle, where here, if I write around the circle, the scale degrees 1, 2, 3, 4, 5, and 6, you could think about this outer circle as being my C blues, and then in this potential voice leading, the B flat blues, I'm saying 1 becomes 3, 2 becomes 4, 3 becomes 5, 4 becomes 6, 5 becomes 1, and 6 becomes 2. So if you want to visualize it that way, that might help some of you visualize this a little bit more clearly. The order is preserved, but we're rotating things around. And we would check all 6 possible rotations like this to find the 6 possibilities. And the rule says that one of those 6 possibilities will be as small as possible of a voice leading that you can find. Oops. So anyways, as I said, it turns out that in this case, the smallest option just involves shifting everything 1 step within the scale, like this. So let's try to apply this to some other possibilities. In fact, what I want to do is I want to try to use this basic idea to compose a 12-bar blues, a sort of systematic 12-bar blues that uses this idea so that as I change between the different chords, I'll change the scale that I'm using with as little motion as possible. And for my 12-bar blues, I'm just going to want to write a progression that uses the C blues, F blues, and G blues versions of the scales. And we're going to be going 1, 4, 1, 5, 4, 1. That's going to be our underlying chord or scale progression. Again, as we saw in the last lecture, chords and scales basically work the same way as far as voice leading. So I'm thinking about these as sort of chords and scales at once. Now, to do the 5 to 4 motion, we've already figured out what the best voice leading is. It's going to be this thing right here. Because 5 and 4, G and F, are separated by a whole step, just like the C blues and B flat blues are. So I know that when I go from 5 to 4, I'll take the root of the 5 chord, that'll be G, and I'll move it up a semitone to become A flat, the second step of the scale for F blues. But I need to figure out what's the best option for going from 1 to 4 and also from 1 to 5. Those are progressions that involve transposing the scale by a perfect fourth or a perfect fifth, up or down. So that's really the only other thing we're going to need to look for, is how do I manage to do that with as small voice leading as possible. Let's see if we can use the rule to figure that out. If you want to pause briefly, now would be a good time to do that. Let's say we want to go from C blues, and let's figure out how to go from a C blues scale to an F blues scale. So here's my thought process. I guess first of all, I should figure out what notes go in the F blues scale. So the scale has F, A flat, B flat, B natural, C, and E flat. I did not space these out well. And just looking at this, I see that the notes that are closest to C, so if I'm thinking about where C ought to go, one possibility seems like C could stay C. Maybe the next possibility would be C would become B natural. If C stays C, that suggests E flat could stay E flat, F could stay F. This is looking pretty good, right? F sharp would become A flat, so that's moving a little bit. G would become B flat, that's moving quite a lot. And B flat would become B natural. How much motion is that overall? Well, C staying C is 0, E flat also 0, F also 0. That's quite promising. F sharp moving to A flat is 2, G moving to B flat is 3, and B flat moving to B natural is 1. So it's a total motion of 6 overall. For a 6-note scale, that's really not so bad. We could go through and explore the other possibilities, but it turns out that this is indeed the smallest possible connection. So let me write this out in a different way. Instead of writing it out with all these crossing lines, let's just remember the fact that C should stay C. I'm going to select all of this, erase it, and I'm going to write out essentially a mode of the F blues scale. The F blues scale, but treating C as the starting point. All right, so C will stay C. E flat, as we saw, becomes E flat. F becomes F. No motion so far. Now F sharp becomes A flat. G moves the farthest. It goes all the way up to B flat. And B flat becomes B natural. Notice that there are some cases where the scale actually shares notes, so B flat belongs to both scales, but it doesn't get to stay B flat. B flat here actually becomes B natural here. Sort of an interesting thing about doing voice leadings with the blues scale. I don't think we saw anything like that with major and minor triads. And we certainly don't see anything like that with the circle of fifths for diatonic scales. So now I have a nice smooth connection between C blues and F blues. It's almost like changing to a parallel mode of the blues scale, keeping C as the tonic. And this is going to be the basic thing that I want to do as I compose my blues progression. Now, to figure out from C blues to G blues, that's the same transposition but going in the other direction. So you might think, what if I started with F blues and tried to go to the C blues? My root of F is this note right here. What happens to it? It stays the same. So if I go from C blues to G blues, the root C should stay the same and essentially become the third step of the next scale. So let's work that out together. Delete this and say, now we're trying to go to the G blues scale. We figured out that C can stay the same, and now I just need to take everything to the next note in the G blues scale. So G blues, G, B flat, C, C sharp, D, F, and G. So after C, the next note in the scale is C sharp. E flat should move to C sharp. After that, I need a D, so F is going to move down a ways to D. F sharp will move down just a little bit to F. G gets to stay the same, and B flat gets to stay the same. And this as well is 6 semitones of motion overall. 2 semitones going right here, 3 semitones going right here, and then 1 semitone making this connection. 2 plus 3 plus 1 adds up to 6 overall. By the way, notice that as I go from C to G, if we talk in terms of modal brightness, we might be tempted to say that the G blues, treating C as the starting point, is in some sense darker than the C blues, which means that conversely, F is going to be a little bit brighter than the C blues was. All right, so now let's actually hear what this sounds like. I've gone ahead and typed up a short little 12-bar blues that uses this. It's going to be a lick using the C blues scale. I'm going to repeat that lick. Then we're going to shift over to an F chord. And what I've done to write the lick over the F chord is I've just taken all of the notes of the scale and moved them according to the voice leading that we came up with. So we saw in the voice leading to go from C to F, B flat had to become B natural. And likewise, G had to move a good ways up to become B flat, and so on. So I just applied the voice leading that we came up with to this lick to make it become this lick. And then as we go from F back to C, I undo that and we go back to the original lick. Now to get from C to G, I do the opposite voice leading. So for instance, E flat in the C blues scale becomes C sharp in the G blues scale. So this E flat in the lick becomes this C sharp in the lick. And likewise, this E flat right here becomes this C sharp right here. By the way, when I go from the G blues to the F blues, that's transposition down by a whole step. I would encourage you to work this out for yourself and make sure that it makes sense to you why, for example, I have C right here becoming B natural right here, why I have G right here becoming A flat right here. You should be able to go back to this voice leading that we did at the beginning and shift it over to the G and F scales and make sure that it makes sense to you. Let's listen to what this sounds like. Okay, one last thing I want to point out here is that something kind of interesting happens. I've just been sticking strictly with the voice leadings that we've come up with, but somehow doing that, the lick that I end up on, this thing right here, these notes all belong to the C blues scale, but it's a different transposition of the lick within the scale. When we started, we were starting on C, but somehow by the end of it, we've ended up starting on B flat instead. That's because C to G made things get darker, and F to C is going to make things get darker also. But G going to F is kind of like a sideways step, that when I do this sort of thing, there's going to be motion both up and down. For example, C goes down to B natural, but D goes up to E flat. So this connection right here is neither strictly getting darker or strictly getting brighter. It's sort of a sidestep. And so when I go C to G, darker, G to F, sidestep, and then F to C, darker, that makes C to C overall a motion downwards. Every note in this final version of the lick is lower than the corresponding note in this version of the lick. And that's a lot like what we saw back in lectures 1 and 2 when I composed triad progressions within a key. We had some progressions like, I think even 1, 4, 5, 1, for example, that progression as triads can be entirely upshifting, which means that the one chord that you start with is different from the one chord that you end with. We're seeing a really similar sort of thing here, only using the blues scale for the voice leadings rather than using just triads. It's exactly the same theory, but generalized to give us a very different sound world. I think that sort of thing is pretty neat. Okay, so the other thing that I want to do today is I want to give you an intuition for the general rule. That is, why does it work the way that it works? And to go there, the first thing we should do is we should actually see a way in which it fails a little bit, or it's at least slightly counterintuitive. So, limitations of the general rule. And the main limitation is that it will definitely give you a smallest voice leading. That is, it'll find a connection between the chords that's the smallest amount, but it might not necessarily find all connections that are that small amount. So, to start off, let's think about working with transpositions of cluster chords. So that is, let's think about C, C sharp, and D. So a half-step cluster that I'm going to write out like this just to give myself some space. And let's think about the voice leadings that will connect this chord to its transposition one step lower. So one step lower, instead of C, C sharp, and D, would be B, C natural, and D flat or C sharp. And of course, that involves overall 3 half-steps of motion, since each one of these voices went down by 1 for a total distance of 3 between these two chords. Okay, and that's definitely going to be the smallest amount of motion between these. This is the connection that my rule would give us between these two chords. But what I want to point out is I can find another way to connect these chords that will also be just 3 half-steps of motion, but my rule would never find it. And the reason that works is I could say, well, look, this chord and this chord both have C natural, and they both have C sharp. So what if I wanted to look for a connection that kept the C natural the same and kept the C sharp the same? If I did it that way, the thing that's going to have to change is the D is going to have to move all the way down to B natural. So these two guys don't move at all, but then this guy is going to move a lot. We've sort of offloaded all of the three semitones of motion onto a single voice. So you'll agree that if we're measuring distance this way, these are tied, they both involve three semitones of motion. But only one of them is going to show up through a general application of my rule. And that's because if I'm thinking about this as like a root, let's just call it 1, 2, and 3, right? If I'm thinking about 1, 2, and 3 connecting to 1, 2, and 3, the rule finds 1 going to 1, 2 going to 2, and 3 going to 3. So that's this right here. This other thing that the rule doesn't find, this B down here is actually the 1. So here we have 3 going to 1, 1 going to 2, and 2 going to 3. The difference between these two, and the reason that the rule finds one and not the other, is that this one involves, in some sense, a voice crossing, that the D passes through C and C sharp to get down to B. Whereas this one involves nothing like a voice crossing. Every note stays more or less in its lane. So the intuition that the rule is building for us is the following. The rule says you can always remove voice crossings without lengthening the voice leading. In other words, if I go back up here, I have this voice leading down here, and what the rule is saying is, since the D crosses over C sharp and C to get to B, I should be able to find a way to do the voice leading where the D doesn't have to cross over the other two. And in removing the voice crossing, I don't make the overall distance any longer. Why is that the case? Well, let's simplify this a little bit, and instead of thinking about voice leadings between 3-note chords at first, let's actually think about something very simple. And let's not even do this on music notation. Let's just do this for letters on sort of a blank sheet of paper. And let's imagine something like a major third, C and E. And let's imagine the smallest voice leading between that major third and itself. Now, obviously, that's going to be C stays C and E stays E. But suppose we didn't know that at first. Let's suppose we just had no intuitions about this whatsoever, and we imagined that, or we tried a voice leading that went like this. C goes to E and E goes to C. Now, the intuition behind the rule is the following, that overall doing this is the same overall amount of motion as doing this. Let's imagine that we had C sort of go up halfway and then decide to turn around. So it comes back down. E goes down a ways, bumps into C, and then decides to turn around. In other words, it's essentially this, but instead of crossing like so, they meet and then turn away. I think intuitively you might be able to see that doing this sort of thing and doing this sort of thing involve the same amount of motion up and down. The only thing that I've changed is once we got to this point right here where they crossed, I changed who follows what path, but the paths themselves haven't changed. If that's not clear, let me draw this with different colors. So the path that C follows, I'll draw in blue, and the path that E follows, I'll draw in red. So here, C moves up 4 altogether. C moves sort of 2 right here, and then 2 after they cross. E moves 2 right here, and then 2 after they cross. Now, what I'm arguing is, if I do this sort of thing, it's essentially the same voice leading. The distance traveled is the same. E moves down 2, bumps into C, and says, oh, sorry, let me go back up. Whereas C moves up 2, bumps into E, and then decides to move back down. So the total amount of up and down motion is the same either way, right? 2 plus 2 plus 2 plus 2 adds up to 8 altogether. I've colored the paths differently, but the paths are the same. So that's the intuition. You can remove a voice crossing without lengthening the overall amount of voice leading motion. So what that means is, when I'm looking for minimal voice leadings, all I have to do is check the ones that don't involve any voice crossing like this. Now, of course, it actually turns out that sometimes you can remove voice crossings and the end result is better than what you started with. So here, obviously, this was 8 semitones of motion. And if I actually do this, this would be 8 semitones of motion also. But obviously, if I want to take E and let it stay E, I'm not going to have it move down and then back up to E. There's a shorter path from E to E, which is just staying the same. Likewise, C to C, there's a shorter path. C just stays C. And in that case, E moves by 0, C moves by 0. So by removing the voice crossing, I've simplified a distance of 8 into a distance of 0. So we know that removing crossings never makes it worse, but sometimes it can make it better. And the reason that it can make it better, if you have any background in math, basically is related to something that's called the triangle inequality, which says that if I've got a motion that goes like this in 2 different directions, a straight line between the 2 endpoints is always at least as short and often shorter. In regular Euclidean geometry, we know this as the saying, the shortest distance between any 2 points is a straight line. The shortest distance between E and E is just the straight line that stays on E, not meandering away and coming back. So that's really the intuition here, is get rid of crossings. That won't make things worse. And because of that, sometimes when you get rid of crossings, you find a shorter path thanks to the triangle inequality. There's a little bit more complexity here because we can talk about different notions of distance, what we would call different metrics on the space of chords. And what we're talking about here is just adding up the total amount of motion each voice does. That's something that's called the taxicab metric or the L1 norm. But you could explore other senses of distance. It turns out that pretty much any reasonable sense of distance will behave this way. That getting rid of crossings doesn't make things worse, and you have something that's kind of like this triangle inequality. So there's more technical detail that you could get into with the proof here, but this is really the core of the intuition. To take this back to my idea of the cluster chords, we had C, C sharp, and D, and then we had, what was the other chord? We had B, C, and C sharp, like this. And so one of the possibilities that we considered was that C would stay C. Actually, I guess it's probably a little bit more clear if I align them this way, right? So we had the idea that C would stay C, and C sharp would stay C sharp, and then D would become B. So that was one possibility. But then the intuition behind the rule says, I can take this same thing and I can remove the crossings. So D starts here and is going along, but then it bumps into this red path that C sharp was taking, and it says, okay, let's not cross, let's just trade what we're doing. So D bumps into that and then continues on to become C sharp. C sharp, meanwhile, was going along, bumps into D's orange path, says, okay, well, I'll take over your orange path for a while. It goes up, then it bumps into C's blue path and says, okay, well, I'm not going to cross you, so I'll become C. Meanwhile, C was going along happily, bumped into C sharp and said, okay, well, let's not cross, I'll just become B. So here, again, the idea is this thing right here is the same overall motion up and down as this thing right here. All I've done is recolor the paths, so I haven't changed the distance of the paths at all. And then in principle, I could take this and I could simplify the picture a little bit by turning these into straight lines. So here, this orange thing, instead of having it have a corner, I just make it a straight line. Same for the red path, I'll just make it a straight line, and same for the blue path right here, just make it a straight line. That makes it a little bit clearer that this second thing that we got when we removed the crossings is just the original voice leading that I came up with following the rule. C becomes B, C sharp becomes C, D becomes C sharp, everything goes down one semitone. That's what we did back here. So in other words, all of this is where we started, but in reverse. So there's this thing right here with the crossing. And we said, let's remove the crossing and simplify so that we get this. And the rule tells me that I can remove crossings without making the distance traveled any larger. That's exactly what we see, distance of 3 and a distance of 3. Here, removing the crossing doesn't make my overall path any shorter, but that's okay. If I'm only looking for a shortest path, that works just fine. If I want to look for all shortest paths, well, then life gets tougher, and really, you may just have to check all possible paths. That's a more complicated question, kind of related to the question of looking for the second shortest voice leading, which is the thing I've alluded to before as a much harder question than just looking for the shortest. Alright, so that's it for right now. Just a footnote follow-up on Lecture 4. Sorry that Lecture 5 is a little bit delayed. Hopefully this gives you something to tide you over in the meantime.